Good morning, student. Today we are starting with our first topic, rotational dynamics. Dynamics means the study of forces which are responsible for any type of motion. So in this topic we are going to study rotational dynamics. So let us see what's the rotational motion. When any object is revolving about an axis, then we say the object is in rotational motion. When an object is in rotational motion about any axis, then all the particles of the objects are in circular motion about the same axis. Now you can see the diagram given. In this, a disk is rotating about an axis passing through a point O. At the same time, the particle A, which is on the disk, is performing circular motion about the same axis. So before going to rotational motion, let's study the kinematics and dynamics of the circular motion. So what's the circular motion? Motion of a particle along the circumference of the circle is called circular motion. In circular motion, the velocity of the particle is always tangential. The direction of the velocity changes at every instant. Velocity is a vector quantity. It has both magnitude as well as direction. If any one of these magnitude or direction or both magnitude and direction are changing, then we say the velocity is changing. And changing velocity is nothing but the acceleration. So, in circular motion, even though the speed is constant, the direction of the velocity is always changing. Therefore, we say circular motion is an accelerated motion. Again, during the motion, the particle repeats its path along the same trajectory. Hence, the circular motion is periodic motion also. So here we have studied the two characteristics of circular motion. First, the circular motion is an accelerated motion, even though it's a uniform circular motion. And circular motion is periodic motion. So the next point is kinematics of circular motion. So what is kinematics? Kinematics means the study of the physical quantities which describes the motion. So last year we have studied all these quantities and also the kinematic equations. So let's recall them again. So angular displacement means the angle traced by the radius vector at the center, and it is denoted by theta. Angular velocity, it is the rate of change of angular displacement, and it is denoted by the notation omega. Angular acceleration, it is the rate of change of angular velocity, and it is denoted by the letter alpha. Now, the direction of angular velocity is given by right hand thumb rule. When the object is rotating anticlockwise, at that time the angular velocity is upward, and when the object is rotating clockwise direction, then angular velocity is downward. We have also studied the relation between angular and linear velocity, which is equal to V is equal to omega cross R, and also omega is equal to 2 pi n, where n is the frequency. So frequency is the reciprocal of periodic time. So it is equal to 2 pi upon t also. Again, you know that if the speed of the particle in a circular motion is constant, then we say such a motion is a uniform circular motion. In uniform circular motion, even though the speed remains constant, there is always change in the direction of the velocity, and the velocity remains always tangential, and the acceleration responsible for this motion is called radial acceleration. So the radial acceleration keeps the velocity tangential. It helps to change the direction of the velocity and keeps it tangential, and also help to trace the circular path. And it directs always along the radius and towards the center of the circle. That's why we call it as centripetal acceleration. And the magnitude of centripetal acceleration is AR, and it is equal to omega square r. And also we can write in another form, which is equal to v square by r. This you will get by substituting v is equal to r omega. Then, what is non-uniform circular motion? Circular motion of a particle with changing velocity is called non-uniform circular motion. In case of non-uniform circular motion, direction as well as its magnitude of the velocity are changing. So, the responsible acceleration has the two components. One is along the tangent and one is along the radius. So we call it as tangential acceleration and radial acceleration. Here both are linear. So radial acceleration helps or keeps the velocity along the tangent, and it helps to change the direction, while the tangential acceleration is along the tangent and it helps to change the magnitude of the velocity. So it is responsible to change the magnitude of the velocity. So as the magnitude of the tangential velocity changes, the corresponding angular velocity at the center, corresponding angular velocity also changes, producing the angular acceleration alpha. So for increasing speed of alpha is along the omega, and if there is decrease in the speed, then alpha is opposite to omega. Now what we have studied in uniform circular motion, only the acceleration is along the radius, means radial acceleration. The tangential acceleration is 0 in case of uniform circular motion, as the speed is constant. And in case of non-uniform circular motion, there are both the components, tangential as well as radial, because the tangential component helps to change the magnitude of velocity.